In this lesson, I'll show you 4 examples on how to test for convergence in a sequence with limits. This is part number 1. The question reads, for each of the following examples, determine whether the sequence converges or diverges. If it converges, find the limit. To do this, we'll be using the following theorem, which states that if the limit as x approaches infinity for the function f at x is equal to L, and the function f at n is equal to a sub n when n is an integer, then the limit as n approaches infinity of the function a sub n is equal to L. In other words, if we take the limit of these sequence functions and we find out that a limit exists, then it converges, and it converges at that limit. Let me show you with the first one. What we have is the limit as n approaches infinity for a sub n. Therefore, we're taking the limit as n approaches infinity for 1 over n to the power 4, and pretend that we put a very large number in the denominator. 1 over a very large number eventually becomes 0. Therefore, the sequence a sub n converges to 0. Also keep in mind the difference between a sequence and a series. Remember, a sequence isn't added up like you see in series. With series, you sum up all of the terms in the sequence and you end up with a value. That's not the case for sequences. Let's move on to the next example. Let's take the limit of this function. We have the limit as n approaches infinity for our sequence 6n to the power of 2 plus 3n plus 1 all over 17n to the power of 2 plus 18n minus 4. This particular function will require some algebraic manipulation, because if I substitute infinity into this expression, what will end up happening is you'll end up with a situation where you have infinity over infinity, and we don't want that. So what I will do is multiply the denominator and the numerator by 1 over n squared. Let me show you what happens if I do that. So if I multiply the numerator with 1 over n squared and the denominator with this factor, it ends up becoming 6n to the power of 2 over n to the power of 2, which is 6, plus 3 over n plus 1 over n to the power of 2. And at the bottom I end up with 17 plus 18 over n minus 4 over n. If I take the limit as n approaches infinity here, we have 3 over a very large number, that becomes 0. This becomes 0 for the same reason, and so do these terms, leaving us with 6 over 17. Therefore, we can conclude that the sequence a sub n converges to 6 over 17. Finally, in our last example for question 1, we have a sub n is equal to 5 times sine at an angle of 8n. Remember that sine is a wave function that looks like this. If we have a Cartesian plane for x and y, where this is y and this is x, sine always oscillates between -1 and 1. And it will do this forever. So if we were to take the limit of sine, and we put a very large number into n, you'd always get an output that's between 1 and -1. Of course, that's not the case for our particular function, because we have 5 times sine, and the angle is being multiplied by 8, but the same logic applies. Therefore, this function, this particular sequence, does not exist because of this factor. Let's move on to question number 2. Question 2 asks, suppose the size of a population at time n in years is given by p of n is equal to 500n over 3 plus n, where the population is assumed to change once a year, so n is equal to 1, 2, and 3. What is the population after a very long time? This question is no different than the previous one, so we'll take the limit as n approaches infinity, and our function is 500n over 3 plus n. Substituting infinity into n, or a very large number, will give us infinity over infinity. So we need to algebraically manipulate this. I'll multiply the numerator by 1 over n and the denominator by the same thing. This ends up giving me 500 at the top, and at the bottom, 3 over n plus 1. Think of it this way, 1 over n being multiplied to these two terms. 1 over n times 3 is this, and n over n is equal to 1. Now, if I substitute a very large number to n, this becomes 0, and we have 500 over 1, which is 500. Therefore, over a very long time, the population will approach 500. And there you have it. That is how to test for convergence in a sequence with limits.